Welcome to Lesson 135, Decimal and Fraction Equivalence. Today we're going to talk about how to convert fractions to decimals and how to convert decimals to fractions. So the first thing we want to look at is our tens bars here. I want you to take a minute and I want you to see if you compare the fraction and the decimal with each of the bars. When you come back, we'll go over your answer. Alright, so for the first one, you should have found that it has 1, 2, 3, 4, 5 out of 10 colored in. So that would be 5/10, which is the same thing for its decimal. It has 5 out of 10 colored in, so it's 5/10. You'll notice 5/10 and 5/10 sound exactly the same. For the next one, you had 2 colored in, so that would be 2/10, and we'd find the matching decimal. Here we have 8/10 and 8/10. Notice that it sounds exactly the same when we say it as a fraction and as a decimal. On the next one, we have 9/10 and 9/10. And on the last one, we have 4/10 and 4/10. All right, so I want you to take a moment. I want you to find the fraction of colored in boxes, and then I want you to find the decimal. Remember to look, though, how many boxes are there and how many are shaded in. When you come back, we'll go over your answer. All right, so for the first one, for your fraction, you should have gotten 19 out of 100, which means for your decimal, you should have gotten 19 hundredths. Again, both of them sound exactly the same. Okay, I want you to take a minute, and I believe this one is actually in your notes for you to try to write down. When you come back, we'll go over your answer. All right, so you should have gotten 65 out of 100, so 65 hundredths. And then again, 65 hundredths, so with the last number being in the hundredths place, for your decimal. All right, so when we're taking a decimal, so you notice that a lot of decimals and fractions, they can be equivalent. They're the same number, but they're written in a different form. So both of these two numbers represent the same amount. They're just written one as a fraction and one as a decimal. Okay, these are the numbers that are in between our whole numbers. So this number would be between 0 and 1 because it's 0 and this much. So on the number line, it would be closer to 1 than it would be to 0, but it wouldn't be 1 because it doesn't have enough pieces to be one whole group. All right, so when we write decimals as fractions or as mixed numbers, a place value chart can help you out. So what you want to do is you actually want to think about the decimal in words. So in this case, if we have 0 and 47 hundredths, if I take it and put it in my place chart, I have 0 and 47 hundredths. Well, that means that out of 100, because it ends in the hundredths place, I have 47 pieces. And I don't have any whole groups because in my ones, it's a 0. So 47 hundredths as a fraction is 47 over 100, or as we usually say, 47 hundredths. Okay, I want you to try this next one on your own. You can write it in the place chart, and then I want you to write this decimal as a fraction. When you come back, we'll go over your answer. All right, so for this one, you should have found that you had 8 and 47 hundredths. So again, you have 47 out of 100 because your place value is hundredths, which means you're working with 100 pieces, and you had 47 out of that 100. But this time you had 8 whole groups. So your whole number would be 8. So a decimal is a number written with a decimal is kind of like a number written with a fraction. So it's still, this is how many whole groups you have. So in front of the decimal is how many whole groups you have. And behind it, your fraction or your decimal is how many parts or how many pieces you have out of how many you need to make a whole group. All right, so what I'd like you to do, I'd like you to take a minute and I'd like you to write each of these decimals as a fraction. You have this right here, you're just doing this first column, and when you come back, we'll go over your answers. All right, so in this case, you should have had 34 over 100 because this ends in the hundredths place. This one ends in the thousandths, so you should have 1,000 as your denominator and only 52 as your numerator, because the 0 doesn't mean anything, it's just a placeholder. In this case, you have hundredths as your place value, so 100 is your denominator. 25 is the number of pieces you have, and 2 is the number of whole groups that you have. Right, and this one again, 1,000, and we have 184 pieces out of those 1,000. This is why actually the numbers are a little bit off. You typically think that this is the hundredths place, but because this is telling you how many you have, you can't have 184 out of 100. That would mean you'd have to have a whole number. That's why this is all off a little bit, because this is 184 out of 1,000. Alright, so then here you have 8 out of 100. Again, the 0 is just a placeholder telling us that the hundredths place is where we end, so that's how many pieces we need to make a whole group. And we made one whole group before that. So here we have 1,000 as our denominator, 12 is our numerator, no whole number, 3 as our numerator, and 1,000 as our denominator, and then 3 as our whole number, and 2 over 100. Right, so the place value of the decimal always tells us what our denominator is going to be, which tells us that anytime we're converting from a decimal to a fraction, originally our bottom number can only be a power of 10. So 10, 100, 1,000, 10,000. It can't be 20, 25, 36. It will never be that unless you simplify it to be any of those numbers or anything other than a power of 10. Right, so now, just the same, if you have a fraction that has a denominator of a power of 10, so 10, 100, 1,000, 10,000, you can write your fraction as a decimal. So in this case, we have no whole groups. So we place our decimal, and then I have 9 out of 10. So tenths place is the first one after the decimal, so my 9 has to be in my tenths place. All right, and then let's do 27 1,000ths. So I have no whole groups, but now 27 needs to end in the thousandths place, and thousandths is 1, 2, 3 places after the decimal, so the 7 has to be in the last place, the 2 would go in front, and then in order to make this work, I can't just ignore this, I have to actually place a 0 here. All right, so anytime that you have a number that doesn't make it all the way to the end, you have to put 0 as placeholders in the front. I want you to pause and I want you to try the rest of these, and when you come back, we'll go over your answers. All right, so for this one, again, you have 5 as a whole number, so 5 would go in front of the decimal. 18 100ths, so that means it has to end 2 places after the decimal, which works out nicely because we have the 1 and the 8. In this case, we have 2 as a whole number, and then we have 321 thousandths. So thousandths is 3 places after the decimal, which means that this will work out perfectly because we have 3 digits. So we put it like that. Now here, we don't have anything for a whole number, and we have a decimal, and then we're 1, 2, 3 places after the decimal. In this case, the 5 has to go here, and all of these are placeholders. And then last but not least, we have 4 whole groups. We want to end in the hundredths, which is 2 places after the decimal. So the 4 goes here, and we use a 0 as a placeholder. All right, so sometimes it's not so easy to change a fraction to a decimal because we don't always have fractions that have a denominator of 10, 100, 1,000, 10,000, so on and so forth. However, these fractions are possible to be changed to decimals. All of them are, but these are easy to change as well. Not as simple as these last problems were. However, they're just one more step. So in this case, I want you to take a look at the denominators, and I want you to think, can I change them to 10, 100, 1,000, 10,000, so on and so forth. It doesn't just have to be one of these 4. Remember, the next one would be 100,000, and then it would be 1,000,000, so on and so forth. So in this case, 3/20ths. Well, 20 can multiply to 100. So I take 20 and I multiply it by 5, but what I do to the bottom I have to do to the top. So that's going to give me 15 100ths, which as a decimal would be 0 and 15 hundredths. Right? Now for this one, same idea. If 5 can multiply to 10, it can multiply to 100, but I'd rather keep my number small if I don't have to make it that big. So I multiply this by 2, and I multiply the top by 2. But now remember, this is 5. I don't multiply the 5. The 5 stays the same. I don't all of a sudden have 10 whole groups. I still only have 5. And I have 2 tenths left over. So this would give me 5 and 2 tenths. All right, so what I'd like you to do, I'd like you to pause, and I'd like you to try these last 4. And when you come back, we'll go over your answer. All right, so here we would have multiplied both of these by 2 to get us to 1,000. So it would have given us 2 and 400 out of 1,000, which as a decimal would give me 2 and 400 thousandths, ending in the thousandths place. Here we multiply by 4 to get to 100, because we can't get to 10, but we can get to 100. So this would give me 56 100ths. So as a decimal, that would be 0.56. Okay, I can't get to 10, but I can get to 100. So this one would become 34 100ths, which as a decimal is 0 and 34 hundredths. And here I can get to 10, so I multiply both of them by 2. I get 4 and 8 tenths, which would be 4 and 8 tenths as a decimal. All right, so what made changing all those fractions so easy? We talked about the ones that had a base of a power of 10, so 10, 100, 1,000, 10,000, so on and so forth. Even the numbers like 5, well, 10 works, and 20, and 25, 50, all these numbers can be multiplied to get to 100, 10, 1,000, and these are just a few starters. So any fraction that can be made into an equivalent fraction or already has a denominator of a base power of 10 makes it easy to change our fractions to decimals. So any fraction that can be changed to have a denominator of 10, 100, 1,000, so on and so forth, or any fraction that already has those as a denominator can easily change to a decimal. However, this is not always the case. It's not always that easy. So I need you to go to your vocabulary. We're going to talk about a couple other decimals. So now a terminating decimal, you'll find, is a decimal that has a finite number of decimal places, which means it ends or it stops. So kind of think of like the Terminator. He ended or stopped people. In this case, a terminating decimal ends or stops. So an example of a terminating decimal would be, even though it's very long, okay, as long as it stops, as long as there's no ellipses after or repeating bars, this is a terminating decimal. A repeating decimal is a decimal that has a number or block of numbers that repeat over and over. It does not stop, but it follows a pattern. So a repeating decimal is something like this, so 4, 5, 4, 5, 4, 5, any pattern of numbers, any number. It can be one number, it can be 6 numbers, but they have to repeat. And sometimes you'll see these ellipses, but typically when it repeats, you'll see a bar over the numbers that repeat. So in this case, since the 4 and the 5 repeat in that pattern, we have to have the bar like this. So we're going to talk about fractions that aren't necessarily so nice. So we're going to talk about starting with 1/4. 1/4 can be multiplied to get to 100. So I know that if I take 1/4 and I multiply it by 25, and I multiply the top by 25, I should get 25 over 100, which means I should get 25 hundredths. Now, I want to make sure that this is the answer that I get. That's why I use it as an example. So 1/4 actually means 1 divided by 4. Look at a fraction. You have a number, a line, and a number. It's made to look like a division symbol. Instead of numbers, though, we have dots. So this is why when you see this, it means the same thing. This is the same sign as division. So a fraction is actually a division problem. So in this case, we actually are going to do the division. So we're taking 1 and dividing it by 4. So 1 goes on the inside, 4 goes on the outside. I put up my chair. 4 cannot go into 1, so I put a 0 and I subtract. Bring down the 1. Now in order to add another 0, I have to place a decimal, because if I just add a 0, it would be 10. And I'm not working with 10, I'm working with 1. 4 goes into 10 2 times. Minus 8 is 2. Again, I add another 0. Okay, before I say that 4 can't go into 2, I have to add another 0 and bring it down. 4 can go into 20 5 times, which gives us 0. So as a decimal, 1/4 is 0 and 25 hundredths. Now again, we could change this when using multiplication, but I wanted you to see that the answer comes out the same. So in this case, with these fractions, it's not so nice. You'll notice that in your notes, I gave you a spot to do your division problems. Okay, so I'll do 1/9 with you. So it's 1 divided by 9. If it helps you, write it out. 1 divided by 9, which means 9 goes on the outside and 1 goes on the inside. 9 goes into 1 0 times. Minus 0 is 1. Add a decimal, add a 0, add a box, bring it down. We get 10. 9 goes into 10 1 time. Minus 9. Add a 0, add a box, bring it down. 10. 9 goes into 10 1 time. Minus 9. And you'll notice here we're starting to hit a pattern. And I would typically let it happen 3 times before you say for sure that it's a pattern. But in this case, the 1 is going to keep repeating. So when we write 1/9 as a decimal, we are actually saying 0 and 1/10 repeating. So you can write repeating because that is a repeating decimal, but we should have that line above the top. Okay, so I'd like you to do now, I'd like you to change these fractions to decimals, either using long division or multiplication. Remember, the whole number doesn't change. The whole number always just gets put in front of the decimal before you change it. Okay, so take a minute, pause, and when you come back, we'll go over your answers. Alright, so 1 3/5 should be 1 6/10, and it is a terminating decimal. Okay. And then 3/8 is 0 and 375 thousandths. Again, it was a terminating decimal because it ends, it had a finite number of spots. All right, 1/3 is 0 and 3/10, and it is a repeating decimal, so you should have the line over the 3. Now, if you wrote it like this, that's fine too. Typically, if it's one number that repeats, we just write the one number and put the line over the one number. All right, for this problem, just like the 3/5, we could have just multiplied by 2 and gotten 6/10. And here we can just multiply by 2 and get 8/10. But it would be 4 8/10. So this one, as a decimal, is 4 8/10, and it is a terminating decimal. And then 5/6 is 0 and 83/100 repeating. Okay, I know this is a difficult task, and it probably took you a good chunk of time to get this done. Once you get comfortable, once you're really good with long division, you'll be able to catch if it's a mistake or if you're doing it correctly. Don't worry though, you'll get lots of practice, and I know it'll take time, and I'm not going to give you anything that has this huge long number. Okay, so if you think that you're struggling while you're working in class, make sure to stop, raise your hand, ask a question. All right, so you have a couple of problems in your notebook at this point. I would like you to do these, you can do them first and then do your quiz on Edmodo. Make sure that you read carefully, and if you didn't have the opportunity to write your answer or your numbers in your notebook, make sure to copy them down into your notebook right now if they are not in there. As always, if you have any questions, please be sure to post them to Edmodo so we can go over them in class.